Okay, now I'm going to discuss the whole thing that I learned within these 2 weeks. First of all, Na plus K plus pump, which is having two subunits alpha and beta, and only alpha have Na plus and K plus binding sites. Inside there will be 3 Na plus binding sites. Inside means it will pump the sodium from inside to outside, and outside will be 2 K plus binding sites and also an Aubaine's binding site. Only there will be 2 binding sites, and inside there is another phosphorylation site and ATP binding site, and the beta subunit will have the glycosylation ECF extracellular fluids, the glycosylation sites. Now this is our G protein coupled receptor about secondary messenger generation. Okay, here GS means affect or activate adenylate cyclase. Secondary messenger activate adenylate cyclase. This will give rise to CAMP generation, and that is activate protein kinase A. Now I means inhibit the adenylate cyclase, that leads to disrupting the production of the CAMP, inhibition of the production of the CAMP. If there is no secondary messenger, then there will be no action. Okay, now ZQ means it will activate the phospholipase C. Okay, now phospholipase C is the receptor, I can say, and it will generate the secondary messenger as liberate secondary messenger as DHA and IP3, which immobilize the Ca+2 from the endoplasmic reticulum. Okay, now I can say that activate protein kinase C. This leads to activation of the protein kinase C action. Activate protein kinase C. Here A, here C. Same. Activate protein kinase, activate protein kinase. Here C, here A. That's it. Nothing else is. Okay. Now guanyl cyclase receptor. Guanyl cyclase is the receptor, and I can say second messenger is CGMP production. CGMP is the second messenger, and action is not mentioned. Okay. Now receptor tyrosine kinase అన్నారు. రిసెప్టర్ టైరోసిన్ కైనేస్ అంటే ఏంటి వస్తుంది మనకి? ఎఫెక్టర్ వచ్చేసి టైరోసిన్ కైనేస్, అండ్ సెకండ్ మెసేంజర్ వచ్చేసి మ్యాప్ కైనేస్ వస్తుంది. టైరోసిన్ కైనేస్ ఇస్ రిసెప్టర్ అండ్ సెకండ్ మెసేంజర్ ఇస్ మ్యాప్ కైనేస్ వస్తుంది. కైనేస్ మ్యాప్ వస్తుంది. టీ మ్యాప్ లైక్ దట్ అనుకుందాం. సెరైన్ కైనేస్ మీన్స్ సెరైన్ కైనేస్ ఇస్ ద రిసెప్టర్ అండ్ స్మాట్స్ ఆర్ ద సెకండ్ మెసేంజర్స్. ఫ్రమ్ దీస్ టూ యూ గెట్ సైటోకైన్ రిసెప్టర్ టైరోసిన్ కైనేస్, సైటోకైన్ రిసెప్టర్ టైరోసిన్ కైనేస్. So second messenger will be STAT MAP kinase, and receptor will be tyrosine kinase. Now that's it. And this whole part I will explain just very simple, in a simple manner. You listen just. Okay, now here you can see this is the neuron, and here is the resting membrane potentials, and here is will be the gradient potential, because the action potential generates from the axon hillock. From here the action potential travels up to the nerve endings, and here it will stimulate the other neurons. From here like this it will stimulate. Okay, now what I was going to say is that here there will be resting, and here graded potentials are they may be excitatory or inhibitory. So I can see from here the graph that it is an excitatory mode, and it will bounce. It is a inhibitory and inhibitory, and it will, once it reaches the threshold of minus 70 millivolts, it will rise, means depolarizes to a certain extent, that 30 millivolts, and after that repolarization occurs with the help of the influx of the K plus ions, right? Efflux of the K plus ions, and your depolarization occurs because of the influx of the Na plus ions. Okay, and it will lead to hyperpolarization, because the K plus voltage gated charge what is there now, those are very lazy gates. They open slowly and they close slowly, so more and more of the K plus will diffuse outside. As a result, there will be more negative charge developed, so you will get hyperpolarization. Okay, hyperpolarization that leads to very negative. So in order to compensate this, here the Na plus K plus pump is there now. It will send 3 Na plus outside and 2 K plus inside. So as a result, net there will be a 3 Na plus moving outside, right? 3 Na plus moves outside means you will get more positive on the outside, more negative on the inside. So it will maintain like this. Okay, and here you can see K plus voltage gated channels and Na plus voltage gated channels, and activation gate is this. Okay, now we are moving ahead. You can see here I wrote here CNS chapter 117, introduction to the sensory receptors.